Welcome back, everybody. This is part 3 of trig functions of any angle, and now we're going to talk about reference angles. So let's get ready. I hope you have your notes in front of you from your previous videos because you're going to be using them, and the things that and also the things we've done in class. Okay. So our question now is, how are we going to evaluate angles that are greater than 90 degrees? We've only talked about those special angles, and we've talked about 30 degrees, 45 degrees, 60 degrees, and 0 and 90 degrees. But let's talk about angles that are greater than 90 degrees and how we can evaluate them and find out what the trig functions are for them. Okay, and also we'll deal with negative angles. Okay. In order to evaluate an angle that's greater than 90 degrees or less than 0 degrees, we need to find a positive acute angle. And the word positive and acute are really important here. Positive and acute. All right, so we're going to talk about the definition of a reference angle. Now, this is a long definition. I'm going to give it to you, and then I'm going to ask you to pause this video so that you can actually write it down so that we can tear it apart a little bit. So the definition of reference angle is if you let theta be a non-acute angle in standard position that lies in a quadrant, then its reference angle is the positive acute angle, which we're going to call theta prime. That's what that little apostrophe looks like, formed by the terminal side of theta and the x-axis. Okay, so what I want you to do is pause this video and write this down exactly as it is, and then we'll get back. Okay, so go ahead and pause. Okay, so now we're back. And we want to talk about a non-acute angle. That's going to be an angle that is either more than 90 or less than 0. We're going to right now talk about those that are more than 90. And specifically, we're going to go 90, more than 90 and less than 360 to get started here. All right, so in standard position, you know what standard position is. The initial side is on the x-axis and the terminal side is someplace else, okay? And it lies in a quadrant, which means we're not going to be talking about quadrantal angles. Anything that's 90, 180, 270, 360, we're not going to deal with those right now. Only those that lie inside quadrants 2, 3, or 4. Okay? Its reference angle is the positive acute angle, and once again we're going to call that theta prime, formed by the terminal side of theta and the x-axis. So get that underlined, scored, whatever, so that you can refer back to it. Keep that there next to you as you watch the rest of this video. All right, let's continue. Let's talk about this angle. This is definitely a non-acute angle. And actually, it's 135 degrees, which puts it in the second quadrant. So what we're going to do is we're going to go from the terminal side of 135 degrees to the x-axis. Remember, so that the reference angle is formed by the terminal side of the angle and the x-axis. So how do we find that angle? Well, 135 is a little bit shy of 180, so if we take 180 and subtract 135, we have 45 degrees. And notice that I've made my little green arrow in the positive direction because a reference angle is positive, so we have positive 45 degrees. So 45 degrees is the reference angle for 135 degrees. All right? Let's try another one. Oh, and it is in quadrant 2, and we need to kind of remember that. Sorry about that. Okay, this angle. This angle is definitely greater than 90 degrees. Actually, it's 240 degrees. and 240 degrees. If we want to go ahead and drop or identify our angle, we don't identify it from the terminal side to the y-axis. Never the terminal side to the y-axis. When the terminal side gets close to the y-axis, that's what people tend to do. But no, that's not right. It is to the x-axis. So how far is it from 240 degrees back to the x-axis, which would be 180? Well, it would be 240 minus 180. So our angle here is 60 degrees. So the reference angle for 240 degrees is 60 degrees. And it is in quadrant 3. That's going to become important towards the end of this video. All right, so now we have one that is 330 degrees. It's in the 4th quadrant. And in order to figure out what the reference angle is, I go from the terminal side of this angle to the x-axis. And in order to figure that out, that's going to be 360 minus 330. So there's 30 degrees left to go, and it is in quadrant 4. Let's deal with one that isn't in degrees, but it's in pi radians. So if I want my theta to be 5 pi over 6, I know that 5 pi over 6 is almost 6 pi over 6, which would make it pi, which would be 180. So I'm going to draw it in the 2nd quadrant. I am going to evaluate what the value is going to be from the terminal side to the x-axis, and that's going to be pi minus 5 pi over 6. Well, pi would be 6 pi over 6, because 6 over 6 is 1. So 6 pi over 6 minus 5 pi over 6 is pi over 6. So my angle here is, my reference angle is pi over 6. So the reference angle for 5 pi over 6 is pi over 6. Let's say that you're given 7 pi over 4. How are you going to find what the reference angle is? Well, 7 pi over 4 is almost 8 pi over 4. And 8 pi over 4 is 2 pi, which is all the way around the circle. So you know that it's going to be in quadrant 4. And I'm going to measure from the terminal side back to the x-axis. And that's going to be 8 pi over 4, which is 2 pi, minus 7 pi over 4. So my angle is pi over 4. So the reference angle for 7 pi over 4 is pi over 4, and it's in the 4th quadrant. All right, let's start putting it all together. We are moving to something important here. All right, and what we're trying to do is, given any kind of an angle, how can you figure out what the 6 trig functions of that angle are? Okay, so no calculators, folks. You're going to be doing this without a calculator. We're only going to be dealing with our special angles that you already have, and we want exact answers. So if it's 3, the square root of 3 over 2, that's what we want. We do not want a decimal answer. And you will need 2 things. Well, first thing you're going to need is your chart of your special angles, which I'm going to let you use for now. And the second thing you need is your diagram of where the trig functions are either positive or negative. Your chart of special angles, which everybody should have in your notes, and your diagram of where the trig functions are positive or negative, and that was that little chart where we use the all students take calculus. Okay, what I want you to do is pause this video if you need to go get those, and get those 2 things out in front of you. You're not going to be able to use these forever, but for now I want you to be able to go back and reference them. I do expect you to be able to commit these to memory within the next week or so. But for now, get your chart of special angles out, and get your diagram of where the trig functions are positive and negative, because we're going to go back and forth in order to figure out what our answers are. Okay? Go get them. All right, welcome back. So you know how I am about charts and graphs and such. So what we're going to do in order to solve these problems is we're going to make up a little chart. We're going to write what the problem is that we're trying to find. We're going to determine what the reference angle is. We're going to use that reference angle to determine what the special values are. We're going to decide what quadrant this is in, and then we're going to get our final answer. All right, so let's get to the first example. First example is, I want to find the cosine of 135 degrees. All right, cosine of 135 degrees. 135 degrees is in the second quadrant. So write down 2 for your quadrant. All right, now in order to figure out what my reference angle is, if I'm in the second quadrant, I'm just shy of 180 degrees. So I am, and oh, by the way, and cosine in the second quadrant is negative. You get that from your little all students take calculus. All right, so we have second quadrant, cosine is negative. And so I'm going to do 180 minus 135. So I get 45 degrees. So my reference angle is 45 degrees. Now what I want to do is, what is the cosine of 45 degrees? We're looking for the cosine of 135. I'm going to do that by finding the cosine of 45. And the cosine of 45 is the square root of 2 over 2. So now we have our final answer. We only need 2 things. We need the value, the number value, and we need the sign, whether it's positive or negative. So cosine of 135 degrees is going to be the value of square root of 2 over 2 with a negative in front of it. So cosine of 135 degrees is negative square root of 2 over 2. We found what the value was by using the reference angle, and then we assigned the value positive or negative by the fact that cosine is negative in quadrant 2. All right, so let's try another one. This one's going to be, what's the tangent of 5 pi over 4? All right, 5 pi over 4 is a little bit bigger than 4 pi over 4, which would be pi. So this is going to be in the third quadrant. And tangent in the third quadrant is positive. So I have that information. Now, let's find out what our reference angle is going to be. Well, it's going to be 5 pi over 4 minus 4 pi over 4. If I'm in the third quadrant, I have to subtract 180 or pi in order to find out what my reference angle is. 5 pi over 4 minus 4 pi over 4 gives me pi over 4. So I'm going to take my pi over 4, that's my reference angle. So if I find what is the tangent of pi over 4, the tangent of pi over 4 is 1. So now I have my reference angle of pi over 4. I found the tangent of pi over 4, and I know that in the third quadrant the tangent is positive, so the tangent of 5 pi over 4 is going to be 1 with a positive value in front of it. And there we have it. Are you catching on? I think so. Let's try sine of 300 degrees. Well, 300 degrees is in the fourth quadrant. And you know that sine in the fourth quadrant is negative. So I found out where my value of my angle is, and I know that sine is negative there. So now I'm not quite to 360, so I have to do 360 minus 300. And I find out that the answer is my reference angle is 60 degrees. So my reference angle is 60 degrees. Sine of 60 degrees is the square root of 3 over 2. So I have the sine of 300 degrees is going to be my value of my reference angle, which is square root of 3 over 2, with a negative in front of it. And there you have it. So I hope this helps. Make sure that you do your checkpoints, and I'll see you in class. Bye.